Hello everyone. Welcome back to CloudExpert Solutions AWS Certified AI Practitioner Bootcamp. On behalf of the CloudExpert Solution team, I would like to thank you for joining us and exploring this video. Today, we are diving into Amazon Bedrock RAG and knowledge bases, and important topics for the AWS Certified AI Practitioner exam. Whether you are a developer, data scientist, or just curious about AI, this video will help you understand how RAG enhances AI responses, how to set up a knowledge base in Bedrock, and how to apply this knowledge for AWS Certified AI Practitioner exam. Let's get started. We'll start with what is RAG. RAG stands for Retrieval Augmented Generation. It's a technique that combines two powerful AI concepts: retrieval, that means fetching relevant data from a knowledge base, and generation, which means using a LLM like Cloud, Llama 2, Amazon Titan, or any LLM model to generate accurate answers. Let's review a real-life example of RAG or Retrieval Augmented Generation, and here the problem statement is: a hospital's customer support team is overwhelmed with repetitive questions like, what are the visiting hours? How do I reschedule my appointment? What's covered under my insurance plan? Manually answering all these questions is time consuming, and a generic LLM might provide outdated or incorrect information. As an example, insurance plan coverages change frequently or varies for provider. Now, if you have a generic LLM model that might provide outdated information to customers, then what is the solution? As a solution, we can use Amazon Bedrock RAG to create a chatbot that pulls answer from the hospital's latest document, which is PDFs, websites, or even databases. Now let's review step-by-step RAG creation process and workflows. To start with, or the step 1 is set up knowledge base. That means we need to configure the data sources. For this use case, we need to upload the hospital's PDF manuals like visiting policies, insurance docs to an Amazon S3 bucket. We can also connect the patient portal database or the appointment rules. We can also crawl the hospital's public website for FAQ pages. Once we have identified all the data sources, the next step is we need to create a knowledge base in Amazon Bedrock. You can create that from Amazon Bedrock dashboard knowledge base, and there when you create and select the data sources, that is either S3 bucket, database, or web crawler, or a combination of all, then Amazon Bedrock automatically converts text into a vector embedding, which is nothing but numeric representations for first search. We will cover vector databases and vector embedding in greater depth, and we have dedicated slides for that. Now this was the prerequisites. We first configure the data sources, then we configure the knowledge base in Amazon Bedrock. But vector database creation will be taken care by Amazon Bedrock. Now from user point of view, when user asks a question, maybe the query is, what are the visiting hours? Bedrock first searches the knowledge base for semantically similar text snippets. That means it does not just match keywords, it understands context, which means visiting hours could be referred as guest hours. Using that vector database, Amazon Bedrock understands the context or the semantic relationship between the words. Based on the available information, Amazon Bedrock retrieves the most relevant data snippet. As an example, it can retrieve visiting hours are between 9 a.m. to 7 p.m. daily, and that is referred in policy version 2.1, which was updated in January 2024. However, when you are talking about visiting hours, it understands that emergency room hours is not relevant. That is why if there is information that the emergency room is open 24/7, it is not going to retrieve the data, or it is not going to pass the data back to chatbot. Then the next step is generate a response using LLM. And let's assume that we have a foundation model which is nothing but Amazon Titan. Now Bedrock feeds the retrieved snippet to the LLM for us, which is Amazon Titan, with instruction. As an example, it can provide the context like visiting hours are 9 a.m. to 7 p.m. daily, and which is from policy version v2.1, which is retrieved from the knowledge base. It can provide the user's question, which is nothing but what are the visiting hours, and also it is going to provide instruction on the task that answer concisely and cite the resource. Based on this information, our foundation model or the LLM will generate the output. And let's assume based on the LLM capability, it is generating the output as visiting hours are between 9 a.m. to 7 p.m. daily, and source is hospital policy v2.1. And the last step is output the answer to user, which is the final response with the citations. And as we mentioned here, the example could be visiting hours are between 9 a.m. to 7 p.m. and also it will provide the source of that information. Now to summarize how RAG works in Bedrock, the first step is prerequisite, where you set up the knowledge base. Once the knowledge base is configured, the first process is user query, where user directly asks questions to the chatbot. Then based on that information or based on the question, Bedrock search knowledge base for the relevant information, and then the augmentation process. Here the foundation model, which is Amazon Titan for our case, reads the retrieved documents, and finally it generates the output or the AI response with accurate and citation. Now next we are going to review why we use RAG. The first reason is we want to avoid hallucination, because LLM sometimes make up answers and it will provide the answer as if it is a correct fact. RAG will ensure responses are always based on real data, and it will eliminate any hallucination that the model might generate. It can also generate domain-specific accuracy. If you need your AI model for healthcare or for legal documents, then RAG pulls from specific data sources. It is also cost-effective. In previous modules, we reviewed fine-tuning. Fine-tuning a LLM model is very expensive, whereas RAG is cheaper and faster to implement. And last but not least, answer accuracy. The answers will be always accurate because it is pulled from the latest document, including citations, which will build trust. Now you can understand, without RAG, LLMs rely only on their pre-trained knowledge, which can be outdated or incorrect. RAG fixes this by pulling real-time trusted data into responses. Next, we are going to review vector embedding or text embedding. A vector embedding is a numeric representation of text, image, or other data as a series of numbers, like coordinates on map. And these numbers capture the meaning and relationship between the items. Under vector embedding, each word is assigned a vector, that is array of numeric values, which represents the word in an abstract vector space. Think of it like GPS coordinates. And here are some examples. Maybe the words king and queen, since they are related, they will be very close to each other in the vector space. On the other hand, apple and rocket, these are two different objects and that will be far apart because these are not related. Vector embedding is multidimensional, but let me explain it using a simple two-dimensional representation for easy understanding. Let's assume that we have different data sets. The first is president, prime minister, finance minister. These are related to persons or the roles. The second is football, cricket, tennis. These are games. And the third is orange, apple, pineapple. Now, if you are looking between president and orange, those are unrelated because one is either role or persona, the other is fruit. In the vector space, they will be far apart. When these words are fed to that LLM model, LLM creates the vector representation, nothing but the array of numeric values. And let's assume these are our vector representations. Now, if you plot them in a two-dimensional plot, it will look like this. President, Prime Minister, or the Finance Minister, they will be in this coordinate. Whereas the games like football, cricket, tennis, it will be in this coordinate. And orange, pineapple, apple, the fruits will be in these coordinates. That means words that are semantically similar end up close together in a vector space, allowing vector to encode meaning based on the context. Now you must be asking, why numbers? Why not those words? Because computer understand math, not words. Numbers allow machines to calculate similarity, that means how close those words are in terms of their semantic relationship or in terms of their contextual meaning. Now, in terms of dimensionality, although I explain the vector in a two-dimensional plot, AWS Titan embedding uses 1536 dimensions. Yes, you heard it correct. 1536 numbers per word or sentence Amazon Titan embedding is using. And why this many dimensions? Because more dimensions mean more richer meaning. But you have to understand, more dimension will also slow the computation or it will slow the performance. Now let's review how embedding power RAG in Amazon Bedrock. And let's understand using an example like an user asks which headphone have the best noise cancellation. Now in our previous example, since we have used two-dimensional plots, the vector representations could be like this. Headphones has this coordinate, whereas earbuds has this coordinate, and maybe fruits like banana has this coordinate. Now the distance between these two words are less compared to headphones and banana because these are two unrelated topics. Now to search this answer, as step 1, Bedrock converts that query into vector. Then it will search the vector database for similar vectors. As an example, product documentation can mention noise cancelling earbuds in place of noise cancellation headphones. And the last step is it will retrieve the closest match even the words does not exactly match. And why it is powerful? Because it finds noise cancelling even the user says blocks background sound. With this you can understand it is not matching word or phrase, it is understanding the context or the semantics between the phrases. So far we have used the terminology vector or vector database multiple times. Now you must be asking, what is a vector database or how Amazon vector database works? A vector database is a specialized database that stores data as vector embedding, which is nothing but numeric representations of text, image, or etc. etc. It enables semantic search, that is finding match, not just the keywords. Let's understand this concept even further, or if you have any confusion, let me clarify using a real life example. And I am going to take an example from e-commerce product search. And here my scenario is an online store wants its chatbot to answer product questions. So as part of this scenario, the first step could be we can upload the product manuals, that is the PDF copies and customer FAQ to an Amazon S3 bucket. And then when we will integrate with Amazon Bedrock or when we will create that knowledge base, Amazon Bedrock automatically chunks your document, that is the PDFs, web pages, into smaller text snippet we call as document chunk. And then Bedrock use Titan embeddings to convert the text into vectors. And then all those vectors or the numeric representations are stored in a managed vector database. It could be OpenSearch, it could be Pinecone or other offerings. Now you must be asking, what are the vector databases and what are the difference between them? Let's review one by one. These are the supported vector databases in Amazon Bedrock, and we'll search with Amazon OpenSearch. In terms of AWS integration, since both are AWS product, it has a native integration and you have an option to use serverless Amazon OpenSearch. Amazon OpenSearch is best for full text search or even vector hybrid search. And the key features are it supports filtering by metadata and it has built-in AWS security using IAM. The next option, it could be Pinecone. Please remember, this is an external service. This is not native AWS service. That is why the integration would be external using API based, and Pinecone is based when you have high scale semantic search. In terms of key features, Pinecone is optimized for low latency and it has auto scaling or inbuilt auto scaling. The next option could be Redis Enterprise Cloud. Again, this is an external. This is not Amazon Elasticache Redis. This is Redis Enterprise Cloud. Since this is external service, integration is via API based or external integration, and this is best for any real-time application. Key features are it has ultra fast caching. It supports JSON or vector hybrid queries. If you have a requirement to query using JSON or in terms of vector hybrid, then you have Redis Enterprise Clouds. And last but not least, Aurora PostgreSQL. This is again a native AWS service. That is why you will be able to connect using PG Vector extension. This is best for existing PostgreSQL users. If you already have PostgreSQL database and you want to add that vector queries in one database, then Amazon PostgreSQL is best suit for you, and this is cost effective among all those options. Now you must be asking when to use. Amazon OpenSearch is best for general purpose RAG that will balance performance and features, whereas Pinecone for large scale low latency needs, Redis for real-time applications with caching, and Aurora for existing PostgreSQL workloads. Before we conclude this video, we'd like to give you some exam tips. If you are reviewing this video as part of AWS certified AI/ML practitioner certification, you should not skip this slide, and please try to remember the content of this slide. To start with, Bedrock RAG source databases can be Amazon S3, it could be Confluence, it could be SharePoint, it could be Salesforce, or even it could be web page, website, social media pages where you can set up the crawler. Please remember that RAG vector databases Pinecone and Redis, these are external, while OpenSearch and Amazon Aurora are AWS native. Please do not get confused with Redis with Elasticache Redis. Pinecone and Redis are external. RAG is ideal for dynamic document heavy use cases. If you have some use case for support, legal, healthcare domain, then RAG is ideal. Also, you have to remember the difference between RAG versus fine tuning. RAG is cheaper, faster for dynamic data, that is when the policy updates frequently, whereas fine tuning is better for teaching the model new behavior, that is medical jargon or any terminology or any enterprise specific terminologies. You should know the supported data sources. This is very important. It is in line with point number 1. For this AWS certification, please remember RAG improves accuracy by grounding response in external data. I have observed this phrase in couple of exam questions. Please remember this phrase, RAG improves accuracy by grounding response in external data. Last but not least, please practice scenario-based questions, and you can expect scenario-based questions on when to use RAG versus fine-tuning. That is all for today. You now understand Amazon Bedrock RAG, knowledge base, and how to apply these for AWS certified exam. Please stay tuned and explore other modules from the Bootcamp playlist for a comprehensive understanding of the topics required for the certification. If you found this video helpful, please give it a thumbs up, subscribe for more update, and feel free to drop any question or feedback in the comments. We would love to hear from you. I hope this session helped you gain a deeper understanding and brought you one step closer to your learning goals. Thank you very much for watching and learning with us at CloudExpert Solution. See you in the next module.